In this video, I'm going to take a look at this small Black & Decker vacuum. Its runtime has reduced over time, and let's see if we can figure out what the problem is and solve it. Over time, I've noticed it runs less and less time. For example, yeah. So what I'm going to do here is I'm going to take a look at the batteries in here and see what's going on. So the first thing we need to do is remove these two screws in the bottom. So we'll go ahead and do that. This is pretty straightforward. All right. Okay, now that we've got these two screws out, the next thing you need to do is remove this. You need to make sure it's turned off, push this down, and this rotates back, and then this can be removed. All right, by doing so, you'll review that there's a little plastic piece here that needs to be pushed in. So you push that in, and then you should be able to pry this off, maybe with a little back and forth motion. There we go. So internally, you can see there's not a whole lot. There's a lot of extra space. But basically, they've got 3 lithium-ion batteries. Now, I'm going to put a little caution here, and I'm going to put it on the screen as well. Lithium-ion batteries can be very dangerous. You need to be very careful with what you do with them, because shorting them or impacting them or damaging them physically can lead to a fire. So you want to be very, very careful when dealing with this. And I recommend only doing this if you know what you're doing and being very careful. Generally, these batteries are pretty safe, but when you start handling them and doing other things, you risk an issue. So what happens is these things have what's called a battery management system. And then what that does is that makes sure each battery stays within a certain range of voltage, meaning they don't discharge below a certain voltage and they're not charged above a certain voltage. And each battery is checked individually. And what I found over time is that what happens is these things get what's called out of balance, meaning one of the batteries either charges or discharges too much. And when one of the batteries exceeds either the lower or the upper threshold of voltage, then the whole power gets disabled and turned off. It's not like we're using regular AA cells where, okay, one is a little weaker, but you'll still get power through. But the battery management system will disable all of the voltage if one battery of the 3, any of the single batteries of the 3 exceeds or goes below the thresholds. So this is just a little quick diagram I do of a very simple one battery BMS. But basically, the way this works is you have a BMS, which is a battery management system, and you have a load on one section, and then a battery on the other section. And there's a bunch of circuitry in here that basically does the following. The BMS will cut the load when the battery becomes 3 volts or less, and the BMS will cut charging if the battery is at 4.2 volts or higher. So to demonstrate that a little clearer, I've created these diagrams here. Going in more detail here, basically, this will charge the battery as long as the battery is less than 4.2 volts. When the battery gets to 4.2 volts or greater, the BMS opens up the circuit and the charging voltage and current will no longer go into the battery. The opposite works for discharging. As long as the battery is above 3.0 volts, this will be closed and the load will get power. As soon as the battery gets to about 3.0 volts or below, this opens up, the load no longer gets any voltage or current, and that's what causes the stop. So let's put this together like how our vacuum works. Our vacuum has 3 batteries, each one nominally 3.7 volts. These batteries are going to be placed in series. So on this end here, where we get the power, these are the big wires, that's why they're more solid. We have 3.7 times 3, that's more or less 11.1 volts. Now when the batteries are fully charged at 4.2 or very close to 4.2, we'll end up with 12.6 volts. And when almost fully discharged, we'll have just above 3.0 volts times 3, which will be 9.0 volts. So you'll see there's a bit of a range, 9 volts to 12.6 volts, about 3.6 volts of variation. Getting back to how the BMS works. So basically the BMS is monitoring this total power here. It could monitor that, and when it's below 9.0 volts, it could cut out. But what happens if one of these batteries is at 4.2, the other one's at 3.7, and this one's at 2.9? That's still going to be above your 9.0 volts, but this battery, if you continue to discharge it, it's going to run into problems or shorten its lifespan. So what the BMS does is it actually monitors the individual voltage of each battery separately and at the same time. And if any battery either exceeds 4.2 volts or goes below 3.0 volts, it cuts out, either charging for the 4.2 or the discharging at 3.0. That's basically briefly how this BMS works for this example. There are other BMSs, there's other battery types, but in this particular case, I know these are 18650 cells, and that's pretty much how they work. So what we can do here is measure the voltage on these and see if there's a particular one that's either really close to one of the thresholds. And we can do that by just taking this little cell thing out and we'll carefully put it down here so that we can take a look at it. And we'll get our voltmeter. Okay, so I've got my voltmeter here, and what we can do is just measure the individual voltage of each of the different cells. You can do that by either prying these little pieces out, or you can also use the BMS pads here. I'm going to go ahead and just do it using the pads, being very careful to only touch what I want to be touching here. So we see this battery is at 3.76 volts, not bad. And we go to this next battery down here, and we see we've got about 3.8, 3.7 volts. And we go to this last battery here, which is 3.06 volts. Well, we can see there's a big variation between this 3.0 volt battery and the 3.7-ish volt batteries. So what's happening is this 3.0 volt battery is causing the BMS to cut out entirely and shortening the runtime of the vacuum. Looking at this chart of voltage versus capacity for a lithium-ion battery, and knowing our batteries have 3.0 volts, which is basically discharge, 3.7-ish to 3.8-ish volts, we see that two of the batteries have somewhere between 20 to 40% of capacity remaining. So it's the one battery at 3.0 volts that's causing our vacuum to stop running early. So if we can balance all of these batteries to have the same voltage, we can get the maximum runtime out of this vacuum. So the easiest way to top off at least one of the batteries is simply plug in the normal charger. The normal charger is going to go ahead and charge all of the batteries at the same time until one of the batteries gets to around 4.2 volts. Looking at the charger, we can see it supplies 15 volts at 150 milliamps. So we know it's safe to charge the batteries individually at 150 milliamps. We'll note that for later. Yeah, I've basically plugged in the charger into the outlet, and we're going to go ahead and hook this up here so that it charges. Now, of course, we could have done this before opening up the unit, but I wanted to demonstrate the voltages of the cells when they were close to discharge, and the one particular cell that was down to about 3 volts, which I believe is the cutoff, that caused the whole thing to shut off. Anyhow, this is going to take a while at 150 milliamps, so I'm going to do that off camera, and when it's fully charged, we'll measure the voltages of the batteries and we'll see where we're at. So for this vacuum, I basically charged it until the charging light turned off. And now let's check the balance of the batteries, see if we need to add any extra voltage to any of these. So here we've got 4.088, and then we want the middle one, which goes basically here. 4.1, a little bit higher than the other one. And then the last one here, 3.7. So this is the weak one here. This will need some manual charging in order to balance the batteries. So yeah, okay, let's go ahead and set up our charger to do this. So this side is the positive. We measured that. Let's go ahead and turn this on. Okay, and we did say that this particular unit was 150 milliamp charging. We probably could charge it um, faster than that, but let's just go with what the charger actually provides. It's always very safe to do that. So let's go and hook these up, being very careful. And that is the negative here, and that is the positive here. This is off, so when we hook this up, just connect. And we will be extra careful by measuring the voltage here to confirm, yes, indeed, this is the positive here. All right, so let's just turn that on. And now this is going to feed current into this battery. And when it gets to the 4.2 volts, it's going to stop charging because the voltages are the same. And I'm going to go ahead and just do that off camera. Okay, it's been quite a while and I finished balancing out that other battery. So let's just double check all the batteries, make sure they're more or less about the same voltage. All right, so this one we've got 4.1. Next one we've got 4.1. And the last one here we've got pretty much 4.1 here. All right, that looks pretty good. So let's go ahead and reassemble this and we'll try it out. So I reviewed my notes when I took it apart. Basically, this goes in this way and slides in this way. That's how it came apart. And it's all the way over to the edge here, like that. And then this also goes like this. There's two little slots where this slides in here. You want to make sure you get those in right. Okay. And then now we can just sort of slide the wires in. And this should just go right in. There we go. That seems to work. And then I've got my two screws. Double check this. This has been an issue occasionally. All right, so that takes care of that. And we just need to get the other piece. Okay, and this should just slide in like that. And then you rotate it, and that's it. So it's all set. Now we'll try it out, see if it works. Okay, and it does. And we'll make sure it works when we charge it with the cord. You should have a little charging, and I don't think it should charge for all that long because it was basically fully charged. Well, that wraps up our video. So we now have restored full capacity to our vacuum by balancing the batteries. Thanks for watching. Please like and subscribe. You can watch one of my other videos by clicking one of the boxes above.